Checkpoint question 3. Calculate the enthalpy change when 10 gram methane is burned. Now you are given the enthalpy change of combustion of methane. In case 1 mole methane is burned, it will give you 800 something. Now it's 10 gram. First, we find the number of mole. There is 0.625 mole. Next, we use the ratio and we get the answer like this. Always remember, the negative sign should be included in your answer. Now, you should pay attention. This time, we have considered the number of mole already, so the unit for the final answer is kilojoule, but not kilojoule per mole. Page 16, checkpoint question 4. This is the change from graphite to diamond, and this is endothermic reaction. First, is it a physical change or chemical change? Well, this is a chemical change for sure. The reason behind is simple, because the new product is got different structure and different melting point and boiling point. So of course, new substance is formed. That is chemical change. Question B. What is the type of structure? Yes. Here shows the giant covalent structure. Hope you still remember. Part C. Which one got lower enthalpy? Before this, we can use the enthalpy level diagram. Because the reaction is endothermic, so we can conclude that the graphite should be in lower position, or we can say this is energetically more stable than that of diamond. So our answer will be, here shows, this is an endothermic reaction. So that means the reactant should be in lower position than that of the product. Part D. So what about the enthalpy change for the backward or reverse reaction? Easy. If the forward one is endothermic, so of course the backward one will be exothermic with the same amount. That is here. Finally, in terms of bonding, so why the diamond cannot change to graphite under room conditions? We seldom see that any diamond in the jewelry shop turn into graphite. Why? We know that diamond change to graphite is exothermic. Theoretically, it is an energetical favored reaction. But the reason behind is because it requires breaking strong covalent bond. And here is the answer. You can see we need to break the strong CC bond during the conversion, and this huge amount of energy seems not likely to be supplied by the room conditions, and that's why the conversion is not success. Next one is page 18, checkpoint 1. Now this is the thermochemical equation between nitric acid and sodium hydroxide. I think this is easy. With the information given, the answer is here. In page 20, give 3 possible errors in the experiment. As there is no constraint mentioned in the questions, so the first one must be heat loss to the surrounding. And the second one is the heat capacity of the calorimeter is ignored or assumed to be 0. And the third one is the reaction is not performed in standard condition. And of course, you can figure out more. For example, one of the typical answer will be the product solution is assumed to have same specific heat capacity or density as pure water. Page 21, question 2. So first, what is meant by standard enthalpy change of neutralization? and you can copy from the notes about the definition. B. The chemical equation involved. Now, you should pay attention. This is the chemical equation, but not the thermochemical equation. So, no fraction is allowed. 2 water will be given out, and something more. Because you are given the barium hydroxide is in solution form, so please include your physical state here. Part C. Determine the enthalpy change of neutralization. So let's see. First of all, you should find out which one is limited or which one is in excess. Yes, barium hydroxide seems got fewer in mole, right? But don't forget they have the mole ratio 1 to 2. That means 0.036 mole of nitric acid should be needed theoretically. Finally, nitric acid is in limiting reagent. Next, we need to find out how many mole of water is formed during the reaction. The amount of water formed equals to the amount of nitric acid, 0.024 mole. And the enthalpy change in this reaction is mc delta T. The delta T here is 22 minus 18. So don't forget to add the minus sign. After consider the number of mole, then the answer will be minus 49 kJ per mole. Part D we have finished already. And part E, what you expect from the theoretical value, it should be less exothermic than the theoretical one, less negative. Because again, heat loss to surrounding, the heat capacity of the calorimeter is ignored, right? So this will be our final answer. Question 6 in page 23. So first of all, you need to find the volume for complete neutralization. This is easy, right? The highest temperature is in 20 cm3 of sodium hydroxide. And the maximum temperature change, now this is change. So here, we can find that the maximum temperature is 38 degrees Celsius, right? So the initial one is 20, so the temperature change will be 18 degrees Celsius. C. The equation between sodium hydroxide and HCl, and here is next one. Find the enthalpy change of neutralization. Now, so first, let's highlight some information. The sodium hydroxide is 3m, same for the HCl, and 20 cm3 is for HCl. So don't forget our answer in question A. The energy involved is mc delta T, and the number of mole of water formed this time is same as the number of mole of HCl. That is here. Again, add the negative sign and you get the result. Part E is the same, right? So I try to copy the answer from the previous page. Now this is page 28. Now with the graph paper, you know that you are going to plot a graph how the temperature of the mixture are changed against time. But before that, you are requested to write down the chemical equation between zinc and hydrochloric acid, and here is. As I mentioned before, I highly recommend you to write down the physical state in the questions for this unit with the given data, and here is the graph you're going to plot. So you can see the experiment starts in the 1.5 minute, and you need to not only put the correct graph, but also with the extrapolation work. The final temperature or the maximum temperature is about 30 degrees Celsius. Then the maximum temperature change is 6.6 degrees Celsius. Next, you are asked about the enthalpy change of reaction. Now first, find the number of mole to see which one is in excess or which one is limited. Here shows. With the mole ratio, we know that zinc is the limiting reagent. Next, we're going to calculate the energy released in the experiment with our famous formula, mc delta T. Now, this one is actually the volume times density to get the mass, which most students often neglected. With 1,300 something joules, we consider the energy released per mole of zinc. Because according to the equation, 1 mole of zinc will be involved. The equation is like this. And you can alert that there is a negative sign to illustrate this is an exothermic reaction. And our final answer will be minus 45.3 kilojoule per mole. Question E. So what if we use a more concentrated hydrochloric acid with the same volume in the experiment? Will the enthalpy change be affected? And don't forget, explain your answer. To solve these questions, we need to ask, during the calculation in part D, will the number of reaction change when I use more concentrated hydrochloric acid? Or simplify, is hydrochloric acid is the limiting reagent in part D? The answer is no. If hydrochloric acid is not limited, then with more number of hydrochloric acid will not change the result, right? And here shows the enthalpy change of reaction will not be affected because zinc is limited, so more and more HCl will not bring you more reaction or give you more heat energy. And that's it. Page 30, question 1. You will ask to determine the enthalpy change of reaction between hydrochloric acid and silver nitrate solution, which is a precipitation. So first, you are going to draw a label diagram. Okay, here shows. You can see which part is necessary. First is, of course, the reaction mixture. And don't forget the beaker, expanded polystyrene cup, thermometer, stirrer, and lid. So all these parts are necessary. Use cotton wool or not is optional. Part B, you are given the maximum temperature rise is 1.6 degrees Celsius. And you will ask about the enthalpy change of reaction. Again, we need to find the value by energy change over number of reaction involved. So here is the chemical reaction. Yes, their ratio are 1 to 1. So we find the number of mole of two reactants. HCl is limited. What about the energy change? mc delta T, which is about 300 something. So you can see again, I use the negative sign here because I mentioned the energy change. The enthalpy change per mole of HCl or delta HR will be the amount of energy over the number of mole of reaction involved, about minus 60 something kilojoule per mole. Question C. What about the thermochemical reaction? We just copy the equation above and include our data. And finally, you are asked why the reaction is not applied in hot packs. This is an exothermic reaction, very good. But why we seldom use this in hot pack when we get hurt? Well, the reason behind is simple because they involve corrosive acid. Next, in this displacement reaction, the amount of copper 2 sulfate given the amount of zinc given, temperature rise given. So same as usual, we calculate the amount of copper 2 sulfate and zinc first and see which one is in excess. Then with MC delta T, we can find the amount of heat energy. Finally, put the amount of energy given out over the amount of reaction and we get the value. And here shows the answer. With this answer, you will see why there are two calculation steps, the green one and the purple one. Now, it depends on you, how you interpret the total mass. For the green one, I only consider the mass of the solution only. It's 25 grams. But if you consider there are 4 grams of zinc, then you will get the purple one. Of course, in the exam, both of them are accepted. So here are the missing questions in the Unit 34 notes.